This will be a talk about testing and going beyond testing. So yeah, my name is Michael. Yeah, Misha, Mikhailo, everything goes to me. And I am not from Magenta company, not from Magenta community, but I am from Codeception community. So actually, the story about Codeception was that I started a project for testing. I did it for my company, which I worked by the time. But then, like it happens in small startups, company was closed, and I left with my code, with my project. And the first company I was approached to show it was Magenta, and I showed them, hey, I built a nice testing framework. Do you like it? And they say, yeah, sure. Yeah, let's meet someday and talk about it. So after about like 6 years, I'm here and I'm showing, yeah, Codeception is good, and finally Magenta concluded that yes, it's good enough for being a part of Magenta, and I'm really proud of this fact. And yeah, Codeception has a long story of development and long, I think I started with no experience in testing, and now by building this stuff and working on projects with Codeception, I learned a lot about testing, and this is talk like summarizes my experience, the technical experience of what I learned. So how to do testing better? We always need to understand that testing is like it's really general term, and today I'll be talking about automated testing, not exploratory, not security, but only automating, and even test automation. It's really hard and complicated topic. There are lots of testing conferences. There are like 5 or 4 talks on this, just only this conference about testing. Testing is everywhere, and what we need to understand that testing is complicated, and we need to know that there are different levels of testing. And people always, especially in tech communities, think of testing like unit testing. In QA communities, they think of end-to-end testing. But to understand what testing applies to our case, to our project, we need to know all these levels of testing. So there are 2 differences. We can test the project from the outside by using its interfaces, or from inside by looking into the code, to applying changes to the code and making tests to work with code directly. But we need to do both to make sustainable test suite. So everything can be tested. Yeah, sometimes you will have problems, and you need to understand which problems you will face by applying testing on different levels. So the lower level we have, okay, let's go by these points, and I will tell what do I mean. So unit tests are tests that run across the code parts, around the components, and they're really stable because they're just executing the code, and that's all. While acceptance testing and end-to-end tests, they deal with user interface, and to build this user interface, to show it, we need the real browser, probably we'll need Selenium server, we'll need the real database, and they're not so stable in that execution, because if you have so many services you are relying on, tests can be flaky. But they are mostly stable to changes, because if you have redesigned, rebuild your application from scratch, but you keep the same interface, your tests will still go on. So both of tests are stable, but in very different ways. And acceptance or end-to-end tests, they produce you with wide coverage. So you can execute only one test, but it can cover a great amount of your code base just by hitting your endpoints. While unit test allows you to test all the edge cases, all the goes to details and specification, because you know where these details and specifications hidden. So you need to do both. And sure, you need some investment. Invest your time, and if you build a suite of acceptance tests, you need to invest your time in infrastructure. Yeah, browsers, Selenium server, databases, clean up databases, probably Docker containers. You need to set it up CI server to make your tests run without flakiness. And for projects where you can't use unit testing, the legacy code bases and so on, you need to spend more time in re-implementing unit tests, the tests which you would probably apply to Unity level in acceptance, and build a really cool infrastructure to support this amount of tests. But you can also invest into architecture and make the code stable from scratch and have less pain in re-implementing the same scenarios in acceptance tests. So yeah, you can just keep in mind that you need to spend your time into this. And sure, the speed. For me personally, I would say that developing end-to-end tests is much more faster, because you just tell which elements to click on page and which what do you expect on page, and that's all. While for unit tests, it's really hard to get around and to understand what I want to trigger, what do I expect to see, should I mock the service, should not, and sometimes development of unit testing is not that easy and fast. It's not so straightforward. But yeah, unit tests and integration tests are much more faster than end-to-end tests. So keep this picture in your mind while when you will implement the tests. The next question is, what type of tests and where do I need? And here is the idea. So when we go from the business rules, from the specification, we start with end-to-end tests, with the outer tests. So we describe how the system behaves in its happy path, in its natural state. And then we start adding more and more paths with details. So if user can log in, okay, that's a happy path, and we are trying that user can successfully log in. But if a user provides us with no password, if user is blocked, if user can log in, but he has its limited abilities in system, and all these details, we can add more scenarios to this case. These details should be tested too, but probably not on the outer level, because we already tested the interface. Yeah, user can log in, but if user logs in and he has different permissions, it's probably a detail, and we can test it on unit level. So the more tests you add, they should go to the internal level. And here goes the TDD process. Sure, everyone heard about TDD. So who uses TDD and is their daily job? Oh, I don't. But that's good for you. The good idea about TDD is using these two loops in TDD. So we start with writing the tests around specification, and the test will fail, because you just describe what you want to achieve. And at the beginning, you have no idea how you will achieve it. You don't even have idea what is the successful result will be. And but you start with a failing test, and it will fail always until you get around and fix it. And when you start implement your feature line by line, you are doing adding unit tests. They are failing, you're refactoring, they're making it, and finally, when you understand that you are done, you get to the running acceptance test. Why does this process good? Because it doesn't allow you to commit your feature, because you always have, it doesn't allow you to commit this feature undone, because acceptance tests always fail before you finish the feature. That's why TDD is really nice. And it allows you to discover more details, more stuff you need to unit test. And this constant TDD process helps you to have a mindset which allows you to discover more paths, more edge cases, more specifications, and add more tests to your code. And so by this very brief introduction to testing, I show you that there are different testing levels, and sometimes you need just to think how can this test be implemented in the most simplest way. The most simplest to me as a developer. So will I spend more time on implementing it as unit test, or will I spend more time on implementing it as acceptance test? Yeah, we should understand that some tests will be good or bad in their different ways, but our time counts more than execution time of tests. And yeah, I think this slide tells more than me, and I already told all these points. So let's go to the next section. Oh, yes, some stuff that I need to tell about problems in testing. There are always problems with testing something asynchronous, and JavaScript in browsers, they're all asynchronous, and there's a big problem around it. Third-party APIs, how to deal with them, especially if it's payment providers, and it's really big pain, and there's no good solution, no silver bullet around these problems. What to do, you need to decide for your own cases. Probably you will need to invent some really crazy machine to run all those tests. And yeah, no good solution to these problems. So going to the next section, beyond testing. It's not usually told on testing topics what should we do for data, because we need some test data, we need to manage it in tests. Short tests should be some kind of isolated, and the test data shouldn't intersect. And how we would access database. So if we do unit testing is perfect, because we don't have database, we don't have data manager, it's okay. But if we do need some more realistic tests, we need to access the database. And how can we clean up the data in this case? If you have all kinds of internal tests, we can use the shared connection. The connection the same for the application and for tests. In this case, we can put our tests into transaction and roll back it afterwards. It is the fastest and the simplest solution to clean up data. So in integration tests or functional tests, we don't really bother about the cleaning up. It's already in the box. And if we don't have access to the database directly, if we do the outer tests from interface, we should think more about the cleanup strategies. And we can do it via external database connection, do some custom cleanups, or use API. API, I think it's the most modern way, because you don't need to access your database directly if you are doing interface testing. But API is interface, but for data. And if you need some data to your test, you can just call like your API, create me user, create me product, create me a stock, and this will all be created in your database, and you can access and continue with testing. How can we make data isolated between tests? We can create the data only for one test. We can create the entire database, or we can always use unique data for each test. So all those strategies are pretty valid, and depending on what do you think would be preferable to you, you can choose one. So the most lazy strategy probably would be to create non-intersecting data. So we make sure that each test will create its unique data, and it won't intersect with others. But it may have some problems. Maybe sometimes they do intersect, actually. And to recreate database is also a very lazy approach, but it's slow. If your database is big, recreating it every time, this can be really performance problematic. But you can use Docker. Docker can help it to start faster. And if you use REST API, as I was telling you, you can easily create and delete data, and just enough data for a test to pass, and clean up this data after the test using your REST API. It's really nice, and what's nice about this approach is that you always see what data test needs, and you can add, remove values. Really simple. And how do we define test data? We have these opportunities. So we can define data with database dumps, this big SQL stuff that we should be executed. And yeah, if you have predefined data set you always need to do test on, that's okay. But if the software develops and you add more and more entities to your code base, you need to add more data. And probably SQL is not the best format to keep this data in. And so in testing we use fixtures. Yeah, we add more fixtures, but modern approach is to use fixture generators. They are called factories. And this approach came from Ruby. There is a library called factory bot. It generates fixtures from the rules you have written. In PHP, we have factory muffin library. So you just define the rules how to create data, and you get your data objects. So here how it looks. So we use a Faker library. We define the fields in our data structure and how they should be generated. And then in tests we can say, give me 5 users. Here you go, 5 unique users. And we can even generate subsequent data, and it's really helps in testing, and we don't need to bother with it anymore. Okay, so let's get to the next topic, APIs. REST APIs are everywhere, unless they are GraphQL APIs, yeah? And REST APIs testing, for me, it's so simple, but people still talk about it, and I don't understand why. So actually, what we need to check in testing REST API is 2 things: is the contract, the structure of responses, and data inclusions, that some expected data is inside it. What we shouldn't check is the full format of response. So if we just do testing by string comparison in a REST API, we do something really stupid. So what we need to check is structure and data. Or schema, it's the structure as well. As we use Swagger or other tools to generate the schema, we can use this schema to validate our responses. So if we have this big nested JSON response, how can we test it? So in Codeception, we have a special module for REST testing, and it's really simple because, yeah, at first we need to check that response was correct, that it was JSON, and then we check that some data, not all the data fields, but some data which is important to us in this response, are included in this response. Because actually some data may change always, like created eth fields, updated eth, so data-related fields will always be different. So they shouldn't be tested in here. But IDs and some stable data should be sure included in this test. And then we check the structure. Probably if you use the tools like Swagger, Robo, and Robo, you don't need to implement your own schema check. But if you don't use such tools, you should check this response for some structure. Yeah, some fields, how they are included. Okay, so that's all about REST testing. Unless we do some, we interact with APIs which are remote to our systems. For this, we have different libraries we can use. It's PHP VCR, which is really nice because it can record the responses from the external API, and you can reuse it. And once you call the external API, and then you just use the same responses ever again without doing external connection. Or you can start your own server with a predefined data set. And yeah, these libraries check them out if you need to, if you face the problem of mocking APIs. Going to the UI testing and end-to-end testing when we deal with real browsers, usually developers are too lazy to look into this side because, okay, we have a QA team and they should do their job. We pay money for them, so they will do the web testing and I will never look into their job. Because why? They like automate these typical user patterns. They don't understand our code. You know, we are building one product and we need to communicate more. And probably there are some things about web UI testing you need to know, even if you have the QA team to do the test automation there. At first, we need to communicate more to learn what do they test, what do they automate. Probably it's already tested on the unit level. Maybe it's not so important to make another acceptance test. Sometimes we can suggest them to use better locators because in some cases QAs can use like really long XPaths to locate that element on a page. And it's much easier to approach a developer and tell him, just add the class name to this element so I could find it faster. Also, test QA team use some language for test automation. And it's a big problem if all the team uses PHP and testers use Java, because we can't help each other. We can't do some, so we don't even look into their code. We can't understand what did they implement. But if they use PHP, we as a developers, as skilled developers, can help them to make their code better. We can suggest how can they access our system directly in some its parts with PHP and so on. So it's a really good practice if the QA team uses the same language. And yeah, we can suggest them to use our REST API for data management. So what do we choose for the web browser testing? I think the standard in the industry is Selenium and its different drivers like Chrome driver, Gecko driver, and so on and so on. Selenium is evolving really fast. It's a really good tool, and all the industry wouldn't be there without Selenium. And Selenium is not just a tool, it's a protocol called WebDriver, which can be used to run your tests in the cloud on different systems, not only Linux or Windows. You can select different browsers, different systems, and everything is there. You can run tests wherever you want and how you want. Today, we even have like lots of tools which are going directly from API to the browser. And I think they are like using Chrome DevTools protocol, and so they are looking really nice and shiny. But Selenium is much more stable. So if you're thinking like, oh, should I use Chrome driver directly? Should I use DevTools protocol for my tests? Probably you can try, but your tests will be more stable if you use good old Selenium. So let's take a look in a year or two. Will those tools be popular like Selenium? And in acceptance tests, I usually see this anti-pattern, which are also driven because people are trying to test everything in one scenario. And as we know from a good practice of testing that tests should be concentrated around one feature. And when we do like create, read, update, and delete, and we are testing it in one scenario, we are doing something wrong because we are testing 4 features in one scenario, and when we fail on the last step, or we don't to rerun this test to fix it, we need to go through all the other tests, and it's not a good idea. So what should we do is to split those tests, to create required data via our APIs, not via our interface. So for QAs, it would be a good improvement to their job if they could create the data not only via interface, because it's really slow. It really makes long, slow, unmaintainable tests. And talking about long, slow, unmaintainable tests, yeah, at one day you will have them. If your project grows, if your test code base grows, and you need to start to think about how we will run these tests in parallel. And I think nowadays, so when we talk about parallel testing, it's really, we need to understand that it's not just about executing tests in a few different threads. Okay, PHP doesn't have threads, so we can do it. But even if it had threads and we could use a real parallelization, it won't help us because we still don't need to isolate different data. So we need to make them isolated. And we need to separate the test and isolate processes. So if we interact with database, we need to have like 2 databases for each thread, which is really hard to set up. And yeah, if we start thinking how can we set up manually, you can probably use multiple nodes. We can use multiple databases, multiple web servers, and luckily today we can do everything with Docker, where everything is isolated by design, and you can set up isolated containers, status them, and kill them. So Docker is absolutely perfect for testing, for parallel testing, and there are lots of cloud-based and hosted CIs which use Docker today. So if we already set up everything we need, like CI server, where web tests, REST API tests, we have unit tests, everything looks like perfect, and we can say that, oh, our testing is done, and probably not. We should think beyond just testing. And we should start get the real usage feedback. First, we need to do the monitoring. So we use Google Analytics. We can receive exception notifications. And we should analyze our logs. So users can discover so many bugs that you couldn't even think about it. And it's really, really important to get that bugs, to know that users something discovered. If we got an exception, probably user knows something about systems that we don't. And we can detect bugs from user activity. So it's pretty smart approach. If we have set up Google Analytics the right way, we can see that something happened in our system when our metrics goes down. So if yesterday we had like 1,000 users who went through the checkout process, and today we have 0 users, probably we broke the checkout process. And how would we know it without analytics? Without just and analytics can show where in this flow, in this funnel, at which step it was actually broken. And the next step is you should allow your users to communicate you and to report about problems, because emails on the page is not enough. Not everyone will text you and tell, on this page with this browser at this time I face this problem, please good developers fix them. And you need to help users to report you problems, and to allow them to do it in the simplest way they could do. And this actually helps you also to to communicate with them, to talk. So if user tried to do something really important and he faced error, he probably is really angry. And if you provide them with a good way to communicate, you can talk with him to propose some maybe promotion discounts, something to make him happy and even if he, make him loyal user. So even if you dropped all the data wiped out, you can talk with him, and probably because you are a really nice guy, he will love your service even you did this stupid huge mistake. And yeah, you can talk with your users and learn how they find your application, what they use, what the issues they have. So actually, that's the project I'm currently working on. It's called Bagheera, and it will be available pretty soon. And it's just about this stuff I was telling about user communication feedback, about so user could report issues really fast, and we can fix them. And we just need not just to fix them, but also learn from these mistakes and write the regression tests. So we transform this bug into test, and we are sure that this bug will never happen again because it's automated testing. So in this part of beyond testing, we still need developers. Developers need it everywhere, yeah? And so for Google Analytics, developers can help to set up these goals, which will be used in Google Analytics. So learn their API, how this tracking goes, and so on. Even if our code is technically perfect, it still can work not as user expect, and we need to developers and users to communicate to understand what problems do they face. And after learning user behavior, we are writing regression tests, and we improve our system, constantly improve our system. And I'm to my final slides, and so to summarize my talk, testing is not just about unit tests. You see, I didn't tell anything about unit testing, but I told you about that. There are different testing levels. Even if you have legacy system, you can still write tests. If you have a system, you don't control some parts in Java, some parts in Perl, some parts in C#, you still can test it, but you will have to do it different way. And quality is a really big process, and you can improve it even without tests. If you set up your monitoring correctly, if you set up the logging and notification correctly, you can survive even without testing if you do it really smart way. Yeah, you still will need tests if you want to build good quality applications. And sure, you need to receive user feedbacks, analyze it, and transform it to regression tests. Thank you.